All right. Good morning. Happy Daylight Savings Monday hangover. Yay. So there's a quiz tomorrow. There's a sample quiz posted. The kinds of things that are on it. Geometric series, like recognizing that it somewhere along the line, if something looked like that, you can create the geometric series. And knowing that it will converge to that sum if the thing we're multiplying by is absolute value is less than 1. And if that thing has an x value in it, be able to solve for what x is make this true. And you may see things with the sigma notation and be asked to expand that and recognize as geometric or something else. Taylor series it doesn't fit the geometric thing, so bummer, you gotta do the derivatives and create it. And each term is created by the nth derivative at the center, x minus the center to the n over n factorial. So some of them will ask you just for the fifth term, or the x to the fifth, that's the polynomial expansion. So maybe you need to do 5 derivatives, and maybe you need to do something else. And I'll show you what I mean by do something else on the error sheet that's today's work. And be able to calculate error. Then I'm letting you use a calculator tomorrow. I will be able to tell if you're doing this properly or if brute force, so don't expect that. And the other two, I see them as the same. It's the first term that you're ignoring gives you the error. So there's that. Okay. The worksheet today, I'd like you to try these. These are all pieces of actual AP questions. And I have the sample test posted with the answer sheet, but we can go over any of that. But we should start on this worksheet and we'll go over pieces when you get stuck.
How would you even know that?
Do I just find everyone? Yeah.
By request, there's now 2 optional delta maths out there. The first one is just Taylor polynomials, and I didn't look at them very clearly. I just threw everything in there that they had by request from 6th period. This one is more inclusive, we'll say, of 9.1 to 9.3 concepts. It's optional, And if you did everything and took as long as it takes Delta Math, it estimates it to be 44 minutes. But it's optional. And you can pick and choose whatever topics you are feeling uncertain of.
No, I think it starts in any two. This is the zero first term, this is the second term. We're only doing this like on this, we're only doing this one. Everything else is different. And
I don't think you that's the absolute background.
This is 4. That's 16. Oh, and then I just get the next 4. I guess this. Yeah.
It does start when this is what I did. Is it even
Oh, yeah, because it's center of 5. That's what I'm talking about. Okay, yeah, layers.
So I actually.
Morning, Barons. Sorry for the interruption. This is just a reminder that throughout today, the transition bells will not sound. This is just a reminder, we will not have transition bells today. Thanks and have a great day.
Okay, did you guys figure out the first one? What do we do? Is it geometric, alternating, or Lagrange? Alternating has positive, negative, not geometric has multiplying by negative x squared on the top, but the factorial thing on the bottom messes that up. So, Nick, what do we do with alternating? Okay, well, okay, well, alternating and, well, by alternating, what do we do? Which one is that?
That's x fourth over 5 factorial. We kind of create like a new series that starts there, actually goes.
That is the interpretation of geometric. So alternating, you just take that guy and plug in the spot where so the maximum error is x to the fourth over 5 factorial with 1 plugged in. And this, guys, is a non-calculator question. They expect you to be able to do 5 factorial. Okay. Questions on?
And this works because as you keep adding terms, it just gets more
It's
accurate.
more and more
So
accurate.
this would be the least accurate.
Yes. Because like that's the targeting thing. I overcorrected that.
Okay.
I'm getting closer.
Okay.
To the target. So the first time I stop overcorrected is the biggest mistake.
I feel like she did
Two B. Well. Including.
Also.
Okay.
Oh wait, I was looking for this one. You have to read that and
Okay, question 2, I said they might ask you to do derivatives or just find the example here. Here's a 6-degree Taylor polynomial. They gave you a way to create the derivatives without actually doing 7 derivatives. So you need to be able to read through that. Here's this polynomial. And we need to create the error term. So if this is 6 degrees, I need the 7th derivative. So plugging in 7 for n in each of those things carefully. So the error term is the 7th derivative. Center minus where we're approximating to the 7th over 7 factorial and stuff cancels. This one is clearly a calculator question, and that's why there's the asterisk on it. Yes,
For part A, how much would you have to simplify it?
you don't.
Okay, like you can leave like X and 0, 0 factorial and stuff like that.
I mean, as the grader, I would appreciate simplifying, but if you are gonna make mistakes in the arithmetic, don't. But again, tomorrow you get to use a calculator.
Yeah,
Wait, you?
Most of it, I mean,
Because at the end, I just left it as a fraction.
with 7 factorial on it or whatever. Oh, no, wait, 7
I got
factorials
it. I got it.
because they can't.
Just for fun, just for fun.
I just have maybe X minus 5 to the 7th.
Well, so it's saying the polynomial that we created has some kind of x6 on it. So when I asked what's the biggest error, you need one more term. So this is calculating the error term. And this stuff is that guy who says so it's not meant to be the answer down here. This is the answer for part A. And this stuff is calculating one more yeah, it's plus or minus whatever it is.
I mean, you have to complement the extra term. It just happens. All dividing the extra term, then we find that and solve it. But then for geometry, you have
No, but why are you telling me? Yeah, you wrote this not just 7 or 12. Why did you do that? Because isn't it still the 6
I don't really know about it.
Yeah.
Oh, we're finding the.
Okay, so you already.
It says, so, break down your term,
It's still good, but she said it's the 7 or 10.
Like, how do you figure out that? X minus function,
Okay.
You gotta make it.
that's just my.
So,
but like, could you figure out like?
Everything accurate. Seventy-five actually.
That was funny.
So
this is like the error.
this we asked for 30 degrees, but here it says
Okay.
even all the way out to
Gives
6.
you
This
what
is
you're.
error.
So it would. Okay, so.
So generator.
You get a really
here. 6 degrees. So what is the degree of 6?
Yeah, that's what. Well, it's no because it says.
That's just, there was an. And to figure this out, you just provide, it's and if it's the same series, it'll always be like this format, it'll just be
Yes.
like X, Y, Z.
And it wants all of the terms.
Yeah, and so.
Yeah.
These little Lagrange are bad on the complexity. Oh my god, there's something called Lagrange error band, but.
So number 3, part A.
Error. Bad on the approximation. Explain why error is not estimated by.
Jeremy, you guys on the back yet? Hey, Don.
Yeah, I can just have it.
So,
This is
Well, you know that. And
Is it just
That's
three?
right, but it
yes,
might
3
be
times
the first
the
two
that
was
you have.
the tail term, right?
It's 3 times the like X minus 2 like that. That's the that's the like next term.
So where's the three come from? So we know,
The sixth version of the X is the
Okay, let's just write it out and
So the biggest number you're gonna get is if you
then I see lots of colors.
and yeah, you know 3 has the number.
And we know.
That's actually right. How much you?
So, you know that your first, like, your five is just.
I think like, hold on, you just find it, you know, like the answer of your, yeah, would be that, plus or minus. Your answer would be positive. As far as you can.
We only do that.
No, you're good.
Run this sheet or
Yep.
The first 3 days, are we supposed to like truncate
yeah.
this is the one section I was here the question is asking. Part B. Use this error bound to explain why we can't get to 5. So if your error is,
I use the truncate.
okay,
So.
like, if your error is that big or more, you've tripped over into this, and it's basically just asking you to prove
The max error won't.
that it's not. You guys don't do it that well, because some people leave these 10 to the negative 34. You don't know that zero. They
That
are
would just be like a number.
zero.
Oh,
So
Oh, yeah.
if you have to write it out, 3 zeros and then a number, like the error is pretty small versus if you wrote out 34 zeros, you know, wait, that's, okay. It's just a cautionary thing. Like, I like this question, you guys understand what it's asking.
That's a difference between
I just haven't answered the other question. Am I excluding this? Like, am I excluding
error would have to be.
How does the error help to explain?
Maybe we have to,
So,
Oh, right, because that term's gonna get
oh, okay, wait. Yeah. Maybe we put negative and then
Yeah.
Or how does an error?
Oh, the error is also.
great. Guys, can we look at the last question, number 3? This is like the useful way of doing error. They're like, okay, I used the Taylor polynomial, created it with all these numbers that were just given to me, and then I wanted to use it at 1.5. And I got this approximation. And then they're saying, the actual function at 1.5, could it get down to negative 5? And that's asking you to find the error. So finding the error for this 3rd degree, I need the 4th derivative. They're not making you calculate it. They're saying in this interval, the biggest mistakes that this is going to create is a 3. So they're giving it to you. They're just like, okay, Gabe, use it 3. It's this. So the error term is going to be 3 times x minus the center, and the x that they asked us to use is 1.5. 1.5 minus 2 is 0.5 to the 4th over 4 factorial. And that's within 1 over 128. That's what that comes out to. So the biggest mistake that we could have gotten was this much, and it's plus or minus. Am I going to subtract it from my approximation here or add it? Subtract it, because that's going towards the negative 5. And that, as Eitan put it, I believe he wrote, I wrote more than he did, but that's okay. Oops. Eitan, you had a number,
Yeah, like negative 4.96.
like 7, some 7.
6, or I got negative 4.966142.
Don't need that many, but so the approximation plus the biggest error that could have been an error didn't get me to that value. So what's your error plus or minus whatever that 0.007 amount was? And they might ask, do you cross the line or not? Is the error tolerance, like if this was an engineering thing and the whole thing's gonna fall apart when you get to negative 5, is it stable? Yeah, but it's really close. How well do you trust people? But that's an application of it. Yeah. I said too many words there, but. And again, there's the optional Delta Math practice on all the different things. And you haven't seen a lot of this, your book doesn't show these, but are you okay with that? Like, oh, the maximum error of this 4th derivative or whatever the value of the fourth derivative is at most 3. Are you okay with reading that? This has been an issue the last few years. Kids are like, I don't know what that, I didn't know how to deal. Like it did the derivative for you. You're not okay with it? Well, what does this notation mean?
The fourth derivative.
The fourth derivative's value at some x. And this is saying for all x in here, so it's the biggest mistake that was in all of those numbers is a 3. So they're trying to be nice and just saying, use the 3. I'll do the derivative for you, use the 3. The notation over here, they were like, I'm gonna give you a formula to find the nth derivative, which you didn't actually have to derivatize, but you needed to plug in. Well, if you wanted the 9th derivative, f of 9, plug in n9 for n. Yeah.
Why is that the max error if there's still like more error? Like it's still not -1.
Okay. Why is that the max error? Well, generating, by Taylor series, generating the first ignored term because you overcorrect or whatever. It's, the biggest this is going to be, it's not, the error's not 3, but that coefficient is used in creating that term. It's 3 times, as it says here, x minus the center to the power over 4 factorial. And just said, that's the biggest mistake there is in calculating whatever it is this is modeling. And it didn't reach the -5. Don't know if that's a good thing or bad, but it doesn't reach -5.
Why do you, for the part B, why did you use 1.5 as the center instead of 2?
I'm not using 1.5 at the center. I'm using 1.5 as, I found the polynomial at 2. I want to use that polynomial not at 2, but off of 2. I want to use that polynomial to approximate at 1.5. When I'm at 1.5, using something that was actually designed at 2, how big is my mistake?
So is it like, it's not really x minus the center for that?
Well, the x is the 1.5. The center is 2. Where am I using it at 1.5? So, sorry, if it would be better for you, x minus the center, 1.5 minus 2, is that better? Okay, there, sorry, I wrote backwards. But it's where you're using the approximation minus the center. Because, you know, you guys they're like, oh, this product is not to be used in this other way. We do it all the time. What's the biggest mistake that it's gonna be? Oh, well, it could dismember you. Or, you know, nothing. Maybe nothing happens. What else? Yeah.
On the other side of the inequality, why did you multiply everything I could or 3 by?
Okay, here. Well, any particular term is the nth derivative evaluated at the center, x minus the center to the nth power over n factorial. N factorial. First ignored term, I used 3 derivatives to get the polynomial, so the first ignored term is to the 4th. So I want the derivative to the 4th, and they said the biggest that's going to be is a 3, so I'm going to get rid of this and plug in 3. And as Luke just asked, why is this going on? Well, the center is 2, and where I'm evaluating the function is at 1.5. So what's the biggest delta in that x? It's 0.5. 2 minus 1.5 is 0.5. It was to the 4th, still is, over 4 factorial. I reduced the 3, and 32 times 8 is 128. Like, I get that max error. Yeah? Cameron?
I'm confused, like what do you actually have to write at the bottom?
Something saying my function at 1.5 is at most. The polynomial at 1.5 plus the max error and minus max error. So the real value of f of 1.5 is squished between them, right? So you just calculated up here the polynomial's value. Down here, we just calculated the most you could be wrong is by this much. Add and subtract that much, and it doesn't hit -5. Tom told me the number, -4.96716 something.
So we don't need that first part, that's like if two people can agree.
I need to see that you calculated the error.
No, but I mean like on the writing.
Oh, no,
Okay.
I get overly chatty on these because I never know how much they want. So I overdo, which is not always a good thing. If you say one word too many, like say something incorrect, you've possibly taken a right answer and taken away the point.
If it just says approximate, can I do like the y minus y1 plus x minus x1?
That's linear. I'm not
I remember
approximating.
we did that for like one of the Taylor series that you plug in at front. Have numbers.
Not sure what you're referring to. Where?
I did realize it's
Okay, so in third degree detail, you need all of the terms, so it's concerning. For these, for Taylor series, they're always gonna ask me that, for just linear. It is a first degree Taylor, and they're not. Yeah. So for sine cosine, that's I haven't proven that to you guys yet, but it's not geometric the way it's created was the way.
I go with my
All around. That's my goal.
It's the same way. It just calls a different thing because it's used for series that aren't always.
They got their own thing. Every time we're doing it.
Like even if we just find the next term that's not in the polynomial, plug in your number.
I didn't realize it was a 2-8 thing, I was just like, lost that connection.
It is that. Your answer is after the, it's plus or minus.
I remember her talking about something.
Okay, thanks.
Error equals A over 1 plus 3.
Yeah, I watched
So instead of doing all this, hey, you wrote the chair. Exact value, we can just subtract
Well, and then the range is like.
Also protest. And then like that would give you like the coefficient.
Alright, bro. You get your way the first
You just wrote it up there.
So what do we include the first north over one?
So you're okay with,
Why is the math for why do we need to? Is this for like answering? I didn't pick up the sheet. She said it's optional.
so should I add or subtract that error to see how close I can get?
What's the force that the right? Use the equation. First question, just use the equation that you.
So-
The force I don't know. I know, I was straight up playing with the balloon.
So, or,
It's.
that's as far as you can. The error was so small, it didn't push to how you determine.
The force.
That's
K
bad. It can hold down the maximum
times
value
N
negative 4.9.
negative G times M1, M1, M2 over R squared.
Okay, I understand that, but how do you know how to find 0.2?
You just plug it into the equation.
First ignored term. So generate the next term, series thing.
This case
It's
is steadily slipping. It's like
the derivative,
first week of
the fourth derivative,
I
the
wonder
next
why,
one,
because
x minus where I'm using the value.
ass.
So centered here, and I'm using it there. That was fourth
There's
derivative.
no exception.
Fourth exponent, fourth exponent.
Guys, you subtracted the error from the estimate, and then it still wasn't like -5, but then how do you know that if you subtract like the next term in the error, that it won't be -5? Those aren't the.
The next term in the error makes it more accurate. So the polynomial, I stopped at the third power. So every additional term is only going to make it more and more accurate. So the first one is the biggest mistake. to the fourth power is the biggest the error can be. To the fifth power is even more accurate. So I'm not gonna use later ones because that's an incorrect number. Anyone, check out the postage quiz? Questions on that? Get an idea? Yeah,
Can you explain the series for the sine squared x?
Okay, the series for sine squared x. That was from the textbook, right? That's a homework question?
Yeah.
And there was a hint on the homework that said, use an identity.
Like 0.8 or something.
Oh, yeah, it was
Oh, yeah, this is an equation.
It's 1/2 minus 1/2 times cosine is even, so I'm gonna start with the even powers, which is, x to the 0 minus the squared over 2 factorial plus the 4th over 4 factorial minus 6 over 6 factorial. What goes in the parentheses? No, not x.
Do it.
And gradient distributing out,
And it's, it would actually.
the 1/2 minus the 1/2 goes away, and then if you ask Yes. Oh, thanks for keeping it up. Yes.
Question.